right, Chapter 11, Lesson 4 is the mean absolute deviation. Now here on the warm-up, it says the tables show the number of points two teams scored. So we want to first plot each, it says number 1, plot each set of data on a number line. Okay, it also says find the mean of each set of data and plot the means on the number line with a star. So the first thing we want to do, well, first thing I want to do is I want to find the means. Okay, so to find the mean of Allie's scores, team score, we add up all the numbers and divide by
The number, how many there?
8, right? 2, 4, 6, 8, right? So we have 440 divided by 8. That gives us 55. Same thing with Lena's team scores. We're going to add them together and divide by 8. And they just happen to have the same average, right? So now we're going to plot the data on the number line. So today we are going to find mean absolute deviation. It says here, if you have used the interquartile range to describe the spread of a set of data. You can also use the mean absolute deviation. And please make sure you write down this definition of the mean absolute deviation. This is the average distance between each data value and the mean. Now, to find the mean absolute deviation, we're going to follow these 3 steps. It's very straightforward, okay? Step 1, we're going to find the mean. Step 1, we're going to find the mean, okay? I want you to make sure you write down these steps. Step 2, we're going to find the differences between each value in the data set and the mean, okay? So how do I find the difference between 2 points? Yes, we will subtract. So to find the differences, we're going to subtract. So we're going to subtract the mean and each one of the data values, okay? Once we do that and get all of those differences, step 3 is to find the average of the differences. And that is going to give you the mean absolute deviation. All right, so the table shows the maximum speeds of 8 roller coasters. Find the mean absolute deviation of a set of data. We want to also describe the mean absolute what the mean absolute deviation represents. So step 1 is to find the mean of the data. Okay, so again, we're going to add up all the data, all the numbers, and divide by how many there are. So when we do that, we end up with 64. So the average or the mean of the maximum speeds of the roller coasters is 64 miles per hour. Okay? So now the next thing we're going to do is we are going to find the differences between each data value and the mean. Okay? So to do that, you guys, you're just going to subtract the big number minus the small number. Is everybody clear? Okay, so for 58, the big one between the mean and 58 is the mean, right? So we're going to subtract 64 minus 58, that gives me 6. With 88, 88 is bigger, so we're going to subtract 88 minus 64. That gives me 24. Is everybody clear? Okay, so it's just the big one minus the small one, okay? For 40, the mean is bigger than that, so it's going to be 64 minus 40. 64 minus 40. 60. 64 minus 60. Then we finish getting the differences between the mean and each of the data values. And then we want to find the average of the differences. Okay? So step 3 is find the average of the differences. So that's why I put pluses in here so you can see that I'm adding each one of those differences. Is everybody clear? So you add them all up. We ended up with 100 and divide by how many there are, 8, and we end up with 12.5. So the mean absolute deviation is 12.5, 12 and a half. Then it says describe what the mean absolute deviation represents. So it says here the mean absolute deviation is 12.5. This means that the average distance each data value is from the mean is 12.5 miles per hour. All right, so here we have another example. We have the table shows the speeds of 10 birds. We want to find the mean absolute deviation of the data. We want to round to the nearest hundredth if necessary. Then we're going to describe what the mean absolute deviation represents. So the first thing we want to do, step one, is find the mean of the data, right? So when we find the mean of the data, I've already added these up for you, and there are 10 of them. And now we have 786 divided by 10 data items, and that's going to give me what?
78.6.
Very good. 78.6. You guys remember that little trick I showed you? Since we're dividing by a multiple of 10, the decimal's at the end here, we're going to move the decimal to the left once. That gives me 78.6. Okay? So that's going to be 78.6 miles per hour. All right. Step two is to find the differences between the mean and each one of the data items. So we want to find the differences. So this is where we're going to subtract. Is everybody clear? So remember, big number minus the small number. Okay? So the mean is 78.6. So with 88, we're going to subtract 78.6. And what do you get? Okay. So we get 9.4, right? All right. And then for the next one, we have 72, 72 and 78.6. So this one, we're going to subtract 78.6 minus 72 gives me 6.6. Very good. And then there's the rest of your data. Okay, so we are just subtracting each one of the mean and the data value to get the differences between the two. All right, so when you add up the differences, you get 109.2, right? Then we have to divide by how many data items?
10.
10. So when we divide by 10, what do I do to this decimal? Move it to the left one time. So that's going to be 10.92. Then we want to describe what the mean absolute deviation means. See right here, describe what the mean absolute deviation represents. So it says here, let's see, the average distance each data value is from the mean is 10.92 miles per hour, and that's all there is to that description. So let's write that down. So the average distance each data value is from the mean is 10.92 miles per hour. So now we can compare variations, okay? When we compare, we'll be comparing the mean absolute deviations for two sets of data. And the only difference between what we were doing before and what we're doing now is that there's two of them. Okay? And then we have to take a look and see what's written underlined in red. Please make sure you know this. A data set with a smaller mean absolute deviation has data values that are closer to the mean than the data set with a greater mean absolute deviation. In other words, the smaller the mean absolute deviation, the smaller the number is, the closer the data values are together. Okay? The larger the mean absolute deviation number, the further out they're spread apart, the further they're spread apart. So, for example 2, here I'm not going to go into this in detail, but here we have, on the left-hand side here, we have the top 5 salaries in millions for the New York Yankees. And then on the right-hand side, we have the bottom 5 salaries. We go and we find the mean absolute deviation for each set of data, and then we're going to compare the mean absolute deviation. So here, for the top 5 salaries, the mean absolute deviation is 4.19. You see that? 4.19. For the bottom 5 salaries, it's 0.01. Okay, do you see the difference in the numbers? One is a bit larger than the other, right? So if I compare the two, for the top 5 salaries, they are further apart. The data values are they're spread apart. And for the bottom the bottom 5 salaries, because it's 0.01, it's a smaller number, they're closer together. And if you look at the data, let me see here, you can see that. So here, as compared to here, you see that? So the top 5 are more spread apart than the bottom 5. All right, so here the table shows the running times in minutes for 2 kinds of movies, comedies and dramas. We want to find the mean absolute deviation for each set of data, and if necessary, we'll round to the nearest hundredth. And then we will write a few sentences comparing their variation, just as we did with the baseball information. Okay, so step 1 is to find the mean of both sets of data. Okay, and I've already done that for you. So for the comedy, we have 471. You add them all together, you get 471 divided by 5. That's going to give us 94.2. For dramas, we have 664. We're dividing that by 5 and we get 132.8. Step 2 is to find the differences between the mean and each one of those data items, right? So here we go. The blue is for comedy and the green is for drama. Okay? So once again, you are going to subtract the big number minus the little number. And finally, what is step 3? To add them all together, divide by how many there are. So we want to find the average of each set of data. Okay? So for the comedies that we have here in blue, so the mean absolute deviation for comedies is 4.16, and the mean absolute deviation for the dramas is 12.24. Now, what do those two mean deviations mean? The closer they are together, right? The comedies are closer, the times are closer together, right? Here, because it's a smaller number. Here, the mean absolute deviation is a larger number, so compared to the comedies, the drama movies, their starting times or their running times are further apart. Is everybody clear? So the mean absolute deviation of the running times of comedies is less than the mean absolute deviation of the running times of dramas. So that means that the running times for comedies are closer together than the dramas.